Have you ever wondered what really happens when you click a link? I mean, it feels like magic, right? Instantaneous. But in that tiny split second, there's this incredible high-speed conversation happening between your computer and some server maybe halfway across the world. Well, today, we're going to pull back the curtain and decode that exact conversation.
Yeah, you click a link and poof, the page is just there. But what's going on in that tiny gap between the click and the load? We're going to follow the journey of that one single click from your screen all the way across the internet and back again. Our little journey has 6 main stops. First up, we'll talk about the rules of the road. Then we'll meet the 2 main players, clients and servers. After that, we'll figure out how they find each other's address, and we'll peek into their digital conversation. Then we'll see what language they're speaking, and finally, how they keep all their secrets safe. Okay, first stop, the rules of the road. Think about it. For any 2 computers to talk to each other, they can't just start yelling into the void. They've got to agree on how they're going to talk. They need a shared language, a set of rules. And in the tech world, that set of rules has a name, a protocol. It's the absolute foundation that makes communication possible. Honestly, without protocols, the internet would just be pure chaos, a bunch of computers shouting nonsense at each other. And really, this whole idea is simpler than it sounds. If I write "raise your hand" on a piece of paper and give it to you, you get it. Why? Because we share a protocol, the English language. You know what those symbols mean. A protocol does the exact same thing, but for computers. So what's the main protocol for the web, the one we're here to talk about? It's HTTP, which stands for Hypertext Transfer Protocol. This is the specific language that your browser and pretty much every website you visit agree to speak. All right, so we've got the language, but who's actually doing the talking? Well, in the world of HTTP, every single conversation has 2 key players. You've got the clients and you've got the server. So on one side, you've got the client. That's the asker. It's your web browser, Chrome, Safari, whatever you use, or an app on your phone. Its job is to ask for stuff. On the other side is the server. That's the one with all the answers. It's a really powerful computer, probably sitting in a huge data center, and its only job is to listen for requests and serve up the data. And this YouTube example, it just nails the concept. When you go to watch a video, your phone app is the client. It sends out a request saying, "Hey, can I get this video?" And deep inside a Google data center, a server hears that, grabs the video and says, "Yep, here you go." Client asks, server answers. It's that simple. Okay, so our client needs to ask the server for information. But wait a minute, there are billions of devices out there. How in the world does your browser find the one specific server it's looking for in that huge digital ocean? Well, it's all about translation. We humans use something called a domain name, like youtube.com, because it's easy to remember. But computers, they need a super specific numerical address called an IP address. You can think of it like this. The domain is the business's name, but the IP address is its actual physical street address. And the piece of magic that connects the name to the number? It's called the domain name system, or DNS for short. When you type in youtube.com, your computer basically shouts out to the DNS, "Hey, I need the number for this name." The DNS is literally the internet's giant phone book. It looks up the name, finds the matching IP address, and sends it back. Now your client knows exactly where to go. All right, let's recap. Our client knows the rules of the road, and it's got the server's street address. Now, it's time for the actual conversation. This is the heart and soul of HTTP, the request and response cycle. Now, when the client makes a request, it's not just saying, "Hey." It sends a very specific command called an HTTP method. The one you use all the time is GET, which just means give me the data, like loading a web page. But there are others, like POST for creating new info, PUT for updating it, and DELETE for getting rid of it. These are the basic building blocks for everything you do online. And when the server replies, it doesn't just send the data, it sends back a little heads up called a status code. It's a quick 3-digit number to say how things went. Anything in the 200s is basically a big thumbs up, Success! The 400s mean you, the client, messed up somehow, like the infamous 404 not found error. And the 500s? That means something went wrong on the server's end. So they're talking, but what's the actual stuff they're sending back and forth? The article, the video, whatever it is? It can't just be a jumble of text, right? It needs some kind of structure that both the client and the server can easily understand. These days, the undisputed champion for formatting that data is something called JSON. That's short for JavaScript Object Notation. And the reason it's so popular is because it hits this perfect sweet spot. It's simple enough that we can actually read it, but it's also structured perfectly for computers to process super efficiently. And this slide right here shows you exactly why. Just look at the difference. JSON on the left is so clean and minimal, right? On the right, you have an older alternative called XML. You can see right away it's just wordy. It has all these extra tags. JSON gets the exact same job done with way less clutter, which is a huge deal on the web. Okay, we're at our last stop, and honestly, this might be the most important one. We have this whole conversation happening between your computer and a server. How do we make absolutely sure that conversation is private and nobody else can listen in? The whole difference between HTTP and HTTPS boils down to that one single letter, S. And that S stands for secure. It makes all the difference in the world. With regular old HTTP, your data is sent in plain text. Anyone could just read it. But with HTTPS, that data is encrypted. It's scrambled into unreadable code. So how does this work? Well, it's basically a super clever digital lock and key system. The server gives your browser a public key. Think of that as an open padlock. Anyone can use it to lock a box. Your browser takes its request, puts it in a digital box, and snaps that padlock shut. But here's the crucial part. Only the server has the secret, private key that can open that specific lock. So even if someone intercepts the box, they have no way of seeing what's inside. And that's it. That brings the whole journey full circle, from the protocol to the client server to finding the address and the conversation itself. This simple, really elegant cycle of a client asking and a server answering happens billions and billions of times every single day. It's the invisible engine that powers our entire digital world. But I want to leave you with one final question. This whole request-response model, HTTP, it was designed decades ago for much, much simpler internet. Now, as our world demands things to be more real-time, more interactive, more complex, what comes next? What's the next great protocol going to look like?